Okay, want to finish up with section 5.7. This is part 4 video. And I want to talk to you about still factoring binomials. And I told you at the end of the last video, I said in all binomials, the first thing you do is check for a GCF. But then after that, there's two things that you have to check after you check for GCF. One is it the difference of two perfect squares? We just talked about that. It has to be a minus, has to be two terms, and they have to both be perfect squares. And I told you in the last video, I said, if it's not the difference of two perfect squares and it doesn't have a GCF, then you can stop right there and call it prime. Well, we can't do that now because we're fixing to cover one last method. So if I look at the problem and there's no GCF, and it's not the difference of two perfect squares, there's one other question I have to ask myself. And it's what I'm about to write up right now. And here's the question that you ask yourself. Is it the sum or difference of two perfect cubes? Is it the sum or difference of two perfect cubes? Okay, so let me show you how you can tell if it's the sum or difference of two perfect cubes. So let's talk about this. All right, first of all, 2. What does 2 mean? Two terms. So we're still talking about binomials. But now we're talking about a sum or a difference. That means when you're looking at what I'm about to show you now, it doesn't always have to be a minus. With perfect squares, it has to always be a minus. But with perfect what? Cubes, it can be a what? Plus or a minus. Now, you say, well, Mr. Arnold, I don't know what that word right there means. That's what I want to talk to you about. What is a perfect cube? Well, before I do that, let me ask you this. What is a perfect square? A perfect square is something that will factor as something times itself. For instance, 49, and we've already talked about this. 49 is a perfect square, 7 times 7. 100 is a perfect square, 10 times 10. So something times itself twice, it's a perfect square. So what then is a perfect cube? If you can break it up as something times itself 3 times. Let me give you an example, or several examples. 8. PC is for perfect cube. 8 is a perfect cube because you can write this as 2 times 2 times 2. Or you could write it 2 cubed. That's why we call it a perfect cube. If you can rewrite this number as something cubed, then that's a perfect cube. Let me show you some others. 27. Can you say something times itself 3 times and get 27? Yes. 3 times 3 times 3. Or you could write that 3 cubed. So 8 is a perfect cube. 27 is a perfect cube. 64. Is that a perfect cube? Can you take something times something times something else? And if you don't know or not, just take your calculator and just start trying it. Take 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4. Well, it turns out if you take your calculator and take 4 times 4 times 4, that's 64. So 64 is a perfect cube. Now, what makes 64 unique? Not only is it a perfect cube, it is also a what? Perfect square. 8 times 8. there's not many numbers that work that way. But 64 is a perfect cube and a perfect square. Okay, let's do 8x squared. If you take something times something times something and get 8x squared. You say, well, yes, 2x, 2x, 2x. No, because this is not x what? Cubed. So is 8x squared a perfect cube? No, it's not. What about y cubed? Is that a perfect cube? Yes. Y times y times y. Or you could just write it the way it originally started, was y cubed. Now, what if this was 8m cubed? Something times something times something. Yes, 2m times 2m times 2m. Or 2m cubed. Now, you have to put the 2m in parentheses there. We talked about that earlier with exponents. If you leave the parentheses off, that cube's only on the m, not the 2. So 2m, 2m, 2m is 8m cubed. So that's a perfect cube. What about 1? Of course. 1 is a perfect anything. It's a perfect square root. It's a perfect cube root. It's a perfect cube. So 1 times 1 times 1. So this is what I mean by perfect cube. All right, let's go back up to the name now. So it'll be 2 terms. The sign don't matter with cubes. Does the sign matter with squares? Yes, but it doesn't with cubes. So it has to be 2 terms. It can be a plus or a minus. Sign don't matter. But both of the terms have to be perfect cubes. So let me show you some examples. Well, before I do that, let me do one more number. So 9. Is 9 a perfect cube? No. And the reason is you can't write 9 as something times itself 3 times. And you say 3 times 3. You got to say it times itself 3 times. So no, 9 is not a perfect cube. So let me show you what these, let me just give you a couple. You don't have to write these down because we're not going to ready to work them yet. But I just want to show you. Okay, let's back up. Does this have a GCF? No. Is it the difference of 2 perfect squares? No, because these aren't perfect squares. Is this the difference of 2 perfect cubes? Yes. X times X times X. So that's a perfect cube. X times X times X. That's a perfect cube. 3 times 3 times 3. And you don't have to put the 3 under there. I just usually do it. And it's okay if you write it 3 to the 3rd. All right, let me show you a couple of others. Is this the difference of 2 perfect squares? No, because it's not difference. Is it the sum or difference of perfect cubes? Yes. It's a binomial. Sign don't matter with the cubes. Is this a perfect cube? Yes. Y times Y times Y. Is 64 a perfect cube? Yes. 4 times 4 times 4. Let's do one more. Eight x cubed minus 27y cubed. Does it have a GCF? No. I always check for that first. Next, is it the difference of 2 perfect squares? No, because these aren't perfect squares. It's difference, but they're not perfect squares. Why do I mention that before I do cubes? Because perfect squares are easier to check than perfect cubes are. So GCF, perfect squares, has to be difference or perfect cubes. Okay, are these different? Are these perfect cubes? Sign don't matter. Is that a perfect cube? Yes. 2x, 2x, 2x. Is this a perfect cube? Yes. 3y, 3y, 3y. Now again, if you want to write it this way, there's nothing wrong with doing that either. The main thing is you make sure you're saying, okay, 3y times 3y times 3y, 2x times 2x times 2x. So those are perfect cubes. You'll see why I'm writing that in just a second. Okay, so does everybody see how to recognize the perfect cubes ones? All right. Once you recognize, yes, this is a sum of cubes, or yes, this is a difference of cubes, then how do you go from this how do you get the answer, in other words? How do you go from here to here? Well, this is what makes this one factoring problem different than all of the others. It's because how you have to go from here to here. And the way you go from here to here is by using one of two formulas. And so what I'm going to do is I'm about to write these two formulas up. In order to use these two formulas, you must memorize them. So these are the only two formulas in the whole factoring process that you have to memorize. Now, you have to memorize some things about factoring, like you have to remember, check for a GCF, you have to remember the steps by grouping, but you're not using a formula. To work the cubes problems, you must use one of these two formulas. Now, let me show you what the two formulas are. I know these are not going to make sense, but just write these two formulas down, and then once you write them down, I will explain them. So these are the cubes formulas. So write that down. So what I'm going to do is I'm going to show you how to factor the sum of two cubes and the difference of two cubes. And I'm also going to show you a way to help you memorize these. Now, this is not the formula. The formula is going to come on the right side of the equal. All right, so do this. Here's the formula. Do two sets of parentheses, but make the second set a little longer. Do two sets of parentheses, but make the second set a little longer. Here's why. You'll see this in just a second. In this one, there's only going to be two terms. In this one, there's only going to be two terms. In these over here, there's going to be three terms. All right, let me show you what goes here. A and B. A and B. A square, AB, B square. A square, AB, B square. Now, you might have a question right now. Ms. Friend, I don't know, what do you mean by A and B? I'm going to talk about that in just a minute. Okay, so here's what, if I were you, this is what I would memorize. What are the cubes formulas? AB, A square, AB, B square. AB, A square, AB, B square. Now, here's how you determine the signs. Anytime you square anything, it's always positive. So these two signs right here are exactly the same. Now, let me show you how you determine these two signs. If the problem is the sum of cubes, that means if the problem you're working on has a plus, whatever this sign is, that sign's going to be the same as that. So whatever this sign is, that's going to be that sign. Whatever this sign is, that's going to be that sign. Then your next sign will be the opposite of this one. Your next sign will be the opposite of this one. Now, whatever works for you, but you need to memorize these two formulas. And I'll say this again in just a few minutes. All right. Now, this A and B stuff. Remember whenever we were talking about on your test 1 midterm, you had the slope formula, and we had the X1s and the Y1s and the X2s and the Y2s, and we plugged those numbers in. So a formula you plug stuff into. Now look at these two formulas. What two letters do you see in these formulas? A's and B's. So what we do is we have to determine what to plug in for the A's and B's. And where that comes from is from your original problem. So let me show you. Let's do 3 examples. All right, so let's look at this one. I want to factor it completely. X cubed plus 8. All right, let's back all the way out. What's the first thing I look for? GCF. No. Next, this is a binomial. So all of that other stuff we've been talking about doesn't apply. So what's the only other thing we talked about? Difference of cubes, difference of squares. Is this difference of squares? No, it's not even difference. So it doesn't have a GCF and it's not squares. Now let's try cubes. All right, what has to happen for cubes? The sign don't matter. Is this a perfect cube? Yes. X times X times X. Is 8 a perfect cube? Yes. 2 times 2 times 2. Now you're about to see why I write it this way. You remember your formula had A's and B's in it? Wherever you have an A, you're going to put that X. And wherever you have a B, you're going to put 2. All right, so do this for me. Put your equal sign. Do one set of parentheses, but make your second set a little longer. Now, here's what I'm going to do right underneath it. Right underneath this, look for my red pen. Here, thought I had my red pen. It's okay. All right, right underneath here, here's what I'm going to do. I'm going to put the formula right up under here. Okay, help me remember the formula. What goes here? A, B, A squared, AB, B squared. Last sign is always plus. Always. Now, this first sign is whatever is in the problem. This second sign is switched from that. Now, here's what we're going to do. We're going to replace the A with what? X. And we're going to replace the B with what? 2. So every place you have an A, put an X. Every place you have a B, put a 2. All right, so let's do that. So this would be X plus 2. And then this is going to be X squared minus X times 2. But I'm going to write that 2X. Just looks better. It's okay if you write X2. Plus 2 squared, but what is 2 squared? 2 times 2 is 4. So if you don't have to rewrite this. If I ask you what two things multiplies together, to give you this, those are the two things that multiply together to give you that. Now, could I have ever gotten that without using these formulas? Absolutely not. Now, let me show you 2 other things right quick. First, when you use these 2 formulas, this right here will always look like it'll factor again. It won't. This will never factor again. Okay, next is, here, well, let me just show you right quick. Break up x squared. X and x, because this is the easy case. X squared is x and x. Signs are the same, both negative. X minus, x minus. Two numbers that multiply to give you 4, that add to give you 2. There's not any. So that doesn't factor any further. Now let me show you one other thing, and then we'll do one more video on this. It doesn't look like, if I multiply this out, it doesn't look like there'd be no way I'd get that right there. Watch what happens if I multiply this out. X cubed minus 2x squared plus 4x plus 2x squared minus 4x plus 8. So this is x cubed minus 2x squared and plus 2x squared adds out, plus 4x and minus 4x adds out, and you're left with x cubed plus 8. So yes, I did find two things that multiplied together to give me that. But I cannot work the cubes factoring problems without knowing the cubes formulas. In this next video, I'm going to do a couple of more factoring with cubes, and then wrap up a big note on factoring.